Hello everyone, welcome to part 3. This is our agenda. We'll be discussing about route tables, then something called NAT, VPC peering, VPC endpoints, VPN connections. Before discussing VPN connections, I'll give you some conceptual idea about VPN, then VPC pricing, and finally our design patterns. Route tables. Route tables give direction to network traffic. Suppose a message wants to go from machine A to machine B over the internet. Route tables specify the best way to achieve this task. Let me try to make an analogy with a real life example. Suppose I want to go to New York from Mumbai using Air India. Multiple routes are possible. From Mumbai, the flight can take me to Singapore, Tokyo, and then New York. Another route can be from Mumbai to New Delhi, to London, to Chicago, and then to New York. Or from Mumbai to New Delhi, to Moscow, and then to New York. But the flight can take any of these routes. Internet works in the exact same way. There are hundreds of routers out there around the globe. You can think of these points as individual routers. When you try to send network traffic from say Mumbai to North Virginia, the traffic would travel the entire globe before reaching its destination. In my case, I do not care which route the flight takes. As long as I reach New York, I'm fine. The job of taking me from my source to destination is that of the airlines. In this case, Air India. So I have set my destination as New York and my flight would take me there. So what is my job then? My part in the entire process is to go to Mumbai International Airport and board the flight on time. That is my target. That means to go to New York, my target would be to reach airport on time and board the flight. So I might say if I have to go to my destination, I should be targeted to Mumbai airport. Once I reach my target, it is the airline's duty to take me to New York. I don't care which route does it take. As long as I reach here, I'm fine. Let me create a route table for my travel. So this would be my route table. To go to my destination, which is New York, I should be targeted to Mumbai airport, or my target should be to reach Mumbai airport on time and board the flight on time. Having said that, let's see how route tables work. Route table tells a machine or network where traffic is directed. Directions are defined by routes and route tables. We have this EC2 instance, INST1, 1123 in a public subnet, and another instance, INST2, 581321 in subnet 2, which is a private subnet. Both the subnets are in the same VPC. We have internet gateway, and of course, the internet. This table would contain something called route. This is the famous route table, and this would contain routes for INST1's subnet. Some traffic from INST1 want to go to INST2. Route table would contain this entry. It has two columns, destination and target. Destination is where you want to go. Target is to go there, where do I have to land? As in my case, to go to New York, I had to land to Mumbai airport. So my target would be airport or the flight where I'll board on. Here, target has a value local, which means to go to 5, 8, 13, 21, traffic would have to go to the local router, which is in the same VPC. Some other traffic wants to go to internet via the internet gateway. So route table would contain this entry. Remember 000/0 is internet. To go to internet, my target would be to reach the internet gateway. Then it is up to the internet gateway how it takes me to internet. Suppose there's a host or computer somewhere out there. This computer is outside of my network and can only be reachable over internet. Some traffic from subnet 1 also want to go or to reach to this host. But it can take only this route. Go to internet gateway, then reach internet and then to this machine. Route table would contain this entry. By the way, 6421/32 is the IP address of this machine. So to go to this host, target would be to reach internet gateway. If you see, there are two routes which kind of matches. One has to go to internet and the other one has to go to this machine, which is reachable over internet only. Target for both of them is internet gateway. Which route would be picked in this case? Another jargon, longest prefix match. This is used to select the route or target. As both are correct routes, route priority is given to more specific destination. As 6421/32 is a specific IP address and 0000/0 is generic because it's actually the entire internet, this third route would be chosen. Each subnet must be associated with a route. We have already seen this in our first VPC demo when we associated two route tables to three different subnets. All VPCs come with an implicit router and a main route table which can be modified. When a VPC is created, it gets a default route table. Let me show you that in the console. I'll create a random VPC and we'll see how the default route table looks like. So this is the route table of the random VPC which we just created. Remember one thing, I did not create this route table separately. It was created by default the moment I added this VPC. Now if you see, this is the first route in this table and this is called a local route. This is used for communication within the VPC. That means if you have multiple subnets, if you create multiple subnets inside this VPC and EC2 instances behind those subnets want to talk to each other, so they'll be using this route. As you have seen, every route table contains a local route for communication within the VPC. Next point of discussion is NAT, or network address translation. Let's understand NAT using example right away. This is our VPC and we have internet gateway attached to it. And this is our famous internet. There are two AZs, AZ1 and AZ2. Each AZ has a single subnet. Subnet 1A is public and subnet 2A is private. This is the network address of subnet 1A. We have instances in both the subnets. These instances are in private subnet. They are not connectable from internet, neither they can talk to internet. Think of a scenario where you have to apply some patches for applications residing in these EC2 instances. Or suppose you want to apply some operating system patches and the patches are available only on internet. Or for some reason, the instances need to connect to the internet and send requests only. Like when we installed Apache using yum install httpd. Being in private subnet, there's no way that requests can be sent out to internet. This is where NAT gateway or NAT instances come to rescue. NAT gateway or NAT instance can be placed in the public subnet, and traffic or requests from these EC2 instances can travel to internet via NAT gateway, then via internet gateway. That means traffic would go from EC2 instance out of the subnet to NAT gateway, then to internet gateway, then to internet. Remember, only requests can go out to internet and its corresponding responses are sent back by the NAT gateway. If any request emanates from internet, if say I am sitting here and I want to connect to one of these EC2 instances, so I start a request, an SSH request for these EC2 instances, those would be stopped by the NAT gateway. It will not allow any requests from internet to go into the EC2 instances which are in private subnet. This would be the route table for subnet 2A or the private subnet. Traffic within the VPC, as mentioned earlier, will flow using local router. And traffic destined for internet from these EC2 instances inside of this private subnet will be targeted to either the NAT gateway or the NAT instance. So instead of NAT gateway, you can use a NAT instance also. Instances on private subnet can also connect to other AWS private public services like S3 etc. using NAT gateway. So NAT devices enable instances in private subnet to connect to internet and brings responses back to the instances. Internet cannot initiate any connection to the instances via NAT. NAT devices are created in public subnet only so that they have a connectivity with internet gateway. Otherwise, NAT devices also cannot talk to the internet without the help of internet gateway. There are two types of NAT devices, NAT gateway and NAT instance, and both of them must be created in public subnets. So this is NAT gateway entirely managed by AWS. It is created in an AZ and implemented with redundancy within that zone. That means if you create a NAT gateway, another NAT gateway will be created so that if one goes down, the other gateway can serve traffic. It supports bursts up to 10 Gbps of network bandwidth. Remember, it's bursts. That means if for some times you need a network speed of 10 Gbps, NAT gateway can do that. You have to attach an elastic IP with a NAT gateway. Network ACLs have to be used to control traffic to and from the subnet when NAT gateway resides. The NAT gateway is in a public subnet. So you have to make sure that network ACLs in the public subnet are modified accordingly. Same is the case with network ACL with the private subnet. Then you have NAT instance. It has to be managed by user or by us, and it can be launched using an AMI called Amazon AMI VPC NAT. There's no redundancy. If your NAT instance is down, your internet traffic would be blocked from the private subnet. So you'll have to create your own failover scenario if you have to using NAT instances. Network bandwidth depends on instance type. So if you're using say T2.micro or M4.large instance, then you'll get very less network bandwidth speeds. You can attach both elastic IP or public IP to the NAT instance. And security groups can also be used to control traffic. The reason being, as it is an instance, you can attach a security group. Of course, along with that, you can use NACLs also. Let's look at some differences between NAT instance and NAT gateway. NAT gateway is implemented with redundancy within the same AZ. But in NAT instance, you have to manage the failover yourself using some scripts. NAT gateway supports burst up to 10 gigabits per second. But in case of NAT instance, it depends on the bandwidth of the instance type. NAT gateway is entirely managed by AWS, and NAT instance has to be managed by the customer or by us. So if there are any operating system patches or security patches, we have to apply it ourselves. But in case of NAT gateway, that will be done by AWS. There's no size limitation in NAT gateway. You just create NAT gateway as an entity. But while creating NAT instance, you can mention instance type and size, because you'll be launching the NAT instance or the NAT software in an EC2 instance. In NAT gateway, only NACLs can be used to filter traffic. As I said, for NAT instance, both security groups and NACLs can be used. Elastic IP has to be associated with NAT gateway, and in NAT instance, both elastic IP and public IP can be associated. Public IP is the one which you get after launching an EC2 instance, and it is provided by AWS. Let's see NAT in action now. We'll use the public and private subnet which was created in the previous demo. We'll launch one instance, each on a private subnet and public subnets, and the name would be pub and priv. We'll set up NACLs to control traffic. The pub instance should be able to SSH to the priv instance. We'll try to install HTTPD or Apache using this command in the priv instance. It should fail. Then we'll create and attach a NAT gateway to public subnet. We'll have to modify route tables and network ACL rules to allow the private instance to install HTTPD from internet. We'll attach a public IP to the priv EC2 instance. We'll try to SSH to the private subnet from local machine. It should fail, which will show that NAT does not allow requests from internet to go into instances in private subnet. This is the architecture of our demo. We'll have a VPC. We'll have internet gateway attached to that VPC. There are two AZs. We'll create one public subnet in AZ1A and private subnet in AZ1B. We'll launch one instance each on these subnets. The instance pub would be in public subnet and instance priv would be in the private subnet. Then we'll create a NAT gateway in public subnet. To connect to this internet, the private subnet would send traffic or request to NAT gateway, which will forward it to internet gateway, and from internet gateway it will go to internet, and we should get the response back as well.